In this lesson today, we're going to be looking at rate of change, which as we get close to graphing linear equations on a graph, you will see how this comes to play with that. But let's look back for a minute. Do you remember doing unit rates? We did this a couple of months ago. If you're trying to find the unit rate of 400 miles on 14 gallons of gas, the unit rate would be how many miles did you drive on 1 gallon of gas? So remember that we set up the information as a ratio. So we put the 400 miles on the top and the 14 gallons on the bottom. Now we simply take our calculators and divide. 400 divided by 14. And when we do that, we would find out that it's 28 6/10 miles per gallon. That means for 1 gallon. So finding the unit rate was finding whatever it is that you're measuring and doing it for 1 gallon or whatever else you're measuring. So slope is the rate of change. We're going to begin to look at linear equations, and you need to have the slope in order to graph a line. So rate of change, to figure it out, all you have to do is you're going to take two sets of numbers which are ordered pairs. An x and a y is an ordered pair. You need two of them. And all you have to do is look at the change of y's. That means you're going to take the two y's, you're going to subtract the y's on the top, and then on the bottom you're going to subtract the x's. The change in the y's, or subtract the y's on the top, and then subtract the x's on the bottom. And it looks like this when you see it as an equation. One of these would be y1, this would be x2, y2. So you would subtract the y's on the top, whatever numbers those are, and the x's on the bottom. So let's look at an example here. Ben was asked to find out what the wait time was at an airport. Using the table data, what was the rate of change between 2007 and 2010? Now first, when you look at a table like this, you have two columns. The first column is going to be the information for the x, also called the domain. The second column is always going to be the y, or we also call that the range. Now in this table, what happens is that the x and the y creates an ordered pair. So if this was going to be graphed, for example, we would have a graph. The x always goes on the bottom, so we would put year on the bottom. The y always goes on the top, so we would put the time over here on the y-axis. And we would be graphing this, and these would be ordered pairs. So down here on the bottom you would have years. Let's say this was year 2006, and here's 2006, and it was 105 minutes. And then you would have minutes going up here, and you would find wherever 105 is, and you would have an ordered pair, 2006, 105. So what this creates here is an ordered pair that we can graph. So how many ordered pairs are in this particular table? Well, if you look at the table, we have, let me erase this, we have 1, 2, 3, 4, 5 different ordered pairs. Now to figure out the rate of change, all you need is two of them, because you only have to have a y1 and a y2, an x1 and an x2. In this scenario, it told you which two to use. It says what was the rate of change between 2007 and 2010. So right there it said you're going to use these two ordered pairs. This is x, this is y, this is x, this is y. Now you have to subtract the y's on the top. We have 190 and 145. So the question always is, how do I know which one is y1 and how do I know which one's y2? It doesn't matter as long as you keep it consistent. And here is what I mean by that. First job is to subtract the y's on the top. On the y's we have 190 and 145. So I can either do 190 minus 145, or I can do 145 minus 190. Here's what I mean by keep it consistent. On the bottom you have to subtract the x values now. So now we're going to do the 2007 and the 2010. In the first example I did 190 first. 190 minus 145. Because I used the 190 first, I have to use the 2007 first when subtracting the x's on the bottom. So I'm going to go 2007 minus 2010. In the second scenario, I did the 145 first. Since I did the 145 first, when I subtract the x's on the bottom, I have to do the 2010 first. So it would be 2010 minus 2007. Now what happens when you solve both of these? In the first example, we have 190 minus 145. That would be 45. We have 2007 minus 2010, which is a negative 3. So we have 45 divided by negative 3, which is a negative 15. That means for every year it went down, the negative number says it went down 15 minutes. That's good for an airport because their wait times are getting less. But let's look at the second example. I could have set it up this way. What is 145 minus 190? It is negative 45. 2010 minus 2007 is 3. Now look at these two. It just changes which one has the negative on it, but we know that when dividing with one negative, the answer is negative. So it doesn't matter which way I set it up. Both of them are negative 15, which stands for a decrease in 15 minutes per year. So you're going to find two ordered pairs, subtract the y's on the top, subtract the x's on the bottom, and that gives you the rate of change, which is also, as we're going to find out later, the slope of the line. Cole was asked to find out what the weight of the winning pumpkin was at his local fair. Using the table of data, what was the rate of change between 2006 and 2009? Again, we have 1, 2, 3, 4, 5 order pairs, but it specifically tells you which two to look at, and we only need two. It tells you 2006 and 2009. So these are the order pairs that we're going to use. There's the x, the y, here's the x and the y. Remember, we're going to subtract the y's on the top. I'm going to do 219 minus 168, and if I set it up that way, then I know that since I used 2019 first on the top, for the x I have to use 2009 on the bottom first, so 2009 minus 2006. Now let me just back up here a minute. People get confused sometimes about x's and y's, and when you're subtracting the y's on the top, it helps sometimes to go ahead and circle the y's so you can remember these are the two that I have to subtract on top. Then I can subtract the x's on the bottom. 219 minus 168 is 51, and 2009 minus 2006 is 3. Now, 51 divided by 3 is 17, so they increased, because it's a positive number, by 17 pounds per year. We found two order pairs, subtracted the y's on the top, the x's on the bottom. Now there's something different about this table. Notice that the first column, which is the x, these are the x column, doesn't have numbers. It just has months of the year. Mo asked his classmates how many of them rode the bus to school in the last couple of months. Use the table data. What was the rate of change between October and February? So it's telling you to do October and February. But what do we do about numbers when they only have listed months of the year, or they could be days of the week? You can just number them 1, 2, 3, 4, 5, because these are consecutive months: October, November, December, January, February. So you can just, since they're consecutive months, you can just number them 1, 2, 3, 4, 5. Remember, we want to subtract the y's on the top. So here's our y, which was 73 minus 41 on the top. So on the bottom, I'm going to do 5. This was 5 for February and 1 for October, which is 4 months. Or you could have counted and said, okay, 1, 2, 3, 4 months. Now we have 73 minus 41, which is 32, divided by 4, and it was 8 students per month. Subtracting the y's on the top and the x's on the bottom. This time we have a graph. And on the graph, I've actually wrote out the ordered pairs for you for each point. It shows the distance a boat traveled at a constant speed. What is the speed of the boat? So you actually have 4 points here. You have 0, 0, This point right here is 150 because it's halfway between 40 and 60. This point is 2, 100. And this point is 3, 150 because it's halfway between 140 and 160. Now, you have 4 points. You only have to use 2 of them, so you get to choose which 2 points to use. Now, if 0, 0 is a possibility, one of the points, if it crosses through 0, 0, always use that one because it's going to make your life easier. So let's say we use this point and this point. We're going to subtract the y's. Remember, with an ordered pair, it's x, y. So here's my y, here's my x, y, here's my y. So I'm going to subtract the y's on the top. So I have 50 minus 0 on the bottom. And since I did the 50 first, I have to do the 1 first when subtracting the x's. 1 minus 0, because there's 0, I just have 50 divided by 1, which is 50. So it's 50 miles per hour. Let's say I would have chose 2 different points, because it could have been any 2 points. Let's say instead I chose, erase this right here, this point and this point. I would have subtracted the y's on the top, so that's 150 minus 100. I would have subtracted the x's on the bottom, 3 minus 2. 50 minus, or divided by 1 is still 50. You still get the same rate of change. You just have to choose 2 of the points. Now this graph, it's not a straight linear equation, a straight line. It goes down and then it goes up. Micah was asked to keep a tally of the number of tweets he looked at each day. Using the information from the graph, what is the rate of change between Tuesday and Thursday? So they're saying these are the 2 points that you are using because it is Tuesday and Thursday. Now again, down here on the x-axis, we do not have numbers. So since they're consecutive days, Monday, Tuesday, Wednesday, Thursday, Friday, we can assign them numbers. 1, 2, 3, 4, 5. So if you look at this order pair right here, the x would be 2, and then it would be 50. So the order pair is 250. Right here, halfway between, 60. Halfway between 55 and 65. On this order pair here, it's on Thursday, we're going to call that 4, and it goes over to 50. So here's our 2 order pairs. So we're going to subtract the y's on the top, 60 minus 50. Then we're going to subtract on the bottom 50 on here. Let me back that up. Let me back that slide up just a little bit. You can do it either way. You can either do 60 minus 50. And if I do the 60 first up here, then I have to do the 2 first. So that'd be 2 minus 4. Or you could reverse it, and you could go 50 minus 60. But if you do the 50 first, then you have to do the 4 first with the x's. Either way, you're going to have 10 divided by negative 2, negative 10 divided by 2, both which result in negative 5. So 5 less tweets per day. So a lot of times they're going to tell you which 2 points to use, and it only takes 2 points to do rate of change. Here's another one like that. We have Anita was asked to find out how many professional baseball games went into extra innings last season. Using the information from the graph, what was the rate of change between 2010 and 2012? So let's look at our order pairs. Here's the x-axis, so this is our x, 2010. And the y was halfway between 17 and 19, so it's 18. For this order pair, we have 2012 for the x, and for the y, we have 24. So we're going to subtract the y's on the top and the x's on the bottom. I set it up subtracting 24 minus 18 on the top. Because I did 24 first on the top, I had to do 2012 first on the bottom. And that would make it 6 halves, which is 3. So 3 extra innings per game. Here's another graph. The graph shows the relationship of Tom's baseball card collection of one person is related to the amount of money he spends on additional cards. Find the rate of change. It specifically gives you the 2 order pairs. So I like to circle the y's to remind me what the y's are. I want to subtract the y's on the top, 50 minus 20. And then I would subtract the x's on the bottom, 5 minus 1. That's 30 divided by 4, which is 8.5 cards per dollar. I hope that this helps you to find rate of change. Remember to find two ordered pairs, subtract the y's on the top and the x's on the bottom.